Hey everybody, today we're going to talk about another way to solve quadratic equations by factoring. This again works for some, but using the quadratic formula works for everyone, so I'm not going to spend a lot of time on the factoring method. But I just wanted to show you this method. So one thing to keep in mind when we're doing these, I'm going to give you quadratic equations. If you were to type it into the calculator, you might see something like this. You're ultimately looking for your zeros. So this might be 0 and -3. All right, you're going to get those same answers, but we're going to do it by using factoring, and the graph can help you out. One thing you're going to need to use is the zero product property, which basically means if a product equals 0. So if you multiply two things together to equal 0, then at least one of the factors must be 0. So let's take a look at some examples, and then I'll show you what I mean by that. So these are the steps for factoring. And this get equation equal to 0, if you see something on the other side of the equation, like this 30, we're going to put it on the other side and just change its sign. That'll be the first step in the other method as well that we'll talk about. Then you're going to factor. We learned 3 ways to factor: GCF using the box method with the 2 parentheses, and difference of 2 squares using the parentheses. And we'll review those today. After you factor, you're going to use a T-bar and set each factor equal to 0 and solve each equation and check. All right, so this first one, again, if I were to type this into the calculator, you would just make sure it equals 0, which it does. Go to y equals, and just type in the left side, x squared plus 12x plus 27. If we take a look at the graph, you may or may not be able to see the zeros. It looks like -3 and -9 maybe. If you go to the table, -3 makes it 0, and -9 makes it 0. So those are the zeros. Those are the answers in the end. So I'm just going to kind of sketch that right here. So -9 and -3 are what we're working towards. All right, now that's graphing. Okay, that's finding them graphically. We want to find them algebraically, so we're going to use our factoring method. So there's no GCF here, so it's going to break up into 2 parentheses. Keep your equals 0. All right, now to figure out what goes in those parentheses, you may remember your box method. You've got your first term, your last term. Now, to get x squared, there's only one way to get x squared. It's x times x. Now, a little trick I had shown you months ago is if you see it on the graph, change its sign. So it's going to end up being x plus 9, x plus 3. But the other way to do it is to look at that product. What are all the ways you can multiply to get 27? 1 times 27 or 3 times 9. You want the pair that's going to add up to the middle term here, positive 12. That's positive 3x and positive 9x. And if you work backwards to multiply to get x squared, we did x times x. To multiply x to get 3x, you'd have to multiply by a positive 3. To multiply to get 9x or to get 27, you'd have to multiply 3 by 9. You'd have to multiply x by 9. So these are what go in your parentheses. And like I said, the shortcut, if you weren't sure what that is, if you look at your graph, these are the zeros. So in your parentheses, it's kind of like, okay, what would you combine with those to get 0? Well, 3 and -3. Oops. 9 and -9. Ignore that. If I can get rid of it. There we go. All right, so now we've factored. Now you do the T-bar, which is what this is, and you set each factor equal to 0 and solve. Because if you're multiplying two things together and they equal 0, at least one of them has to equal 0. So to get x by itself here, we would subtract both sides by -3, or subtract 3 from both sides, and we get x equals -3 is one of our zeros, which we already saw. And the other 0, we'd have to subtract 9, x equals -9, which we saw as well. So if it says to factor, you have to work backwards and figure out what goes in those parentheses using your box method. You could use the shortcut by finding the zeros on the graph and putting the opposite signs in there. But that's just one way to do it. And again, factoring doesn't always work. I don't always like to use factoring. All right, I think you'll like the quadratic equation a little better. All right, this one's different. Remember, you want to ask yourself, is there something in common? Is there a GCF? In the last one, there wasn't. In this one, there is. What do both terms have? They both have an x. So I'm going to pull that out. If I take an x out of 2x squared, it's 2x, right? X times 2x is 2x squared. And if I take, what would I have to multiply x by to get 5x? Just 5. Equals 0. You keep your equal 0. So I've factored that. On the calculator, you might say, well, why would I have to factor if I can just look on the calculator? On the calculator, you can't always see it, and this is going to be one of them. If I type this in, 2x squared plus 5x, and look at the graph, you can see the 0, but you can't see what this one is. All right, so you wouldn't be able to find your answer here. All right, so we found the GCF, and that seeing the 0 on the graph tells me that I do have x as one of my factors. So I set this factor equal to 0, and I can't solve that anymore. There's that 0 that you saw on the graph right here. This one, however, it's a good thing that we are factoring. 2x plus 5 equals 0, because we got to solve it. It's a decimal. Subtract 5 from both sides. 2x equals -5, and then we'd have to divide both sides by 2. X equals -5/2, or -2.5. And if you look at the graph, that does seem about right with its location, -1, -2.5, yeah. All right. But again, if you use the quadratic formula, which we'll talk about tomorrow, you'll see this, that you can get the correct answer by using the same method every time. All right, this one, that 30 needs to go, okay? So if it's positive over here, to get it on this side, we're going to have to subtract it. So I'm just going to rewrite it. I've got my 2x squared, my -7x, and then my -30 goes last. Remember, you want to put it in to standard form. Now with this one, I don't even know if we'll see any of the factors, but let's look, because sometimes it's helpful. So 2x squared minus 7x minus 30. Don't use the negative, it's the minus. If we look at the graph, can't tell what that one is. That one looks like maybe 6, but let's go to the table to be sure. Yep, 6. All right, so again, you can't find the other one this way. So we know one of them is 6. We don't know this one. All right, so with this, there is no GCF. So that tells me I'm going to do 2 parentheses. And I'm going to use the box method to help me. So you put your first term and last term in the boxes. Now, think about this. There's only one way to get 2x squared. I'd have to multiply 2x times x. All right, but now I don't have anything else, so this is where it gets a little tricky. Remember, you multiply these two, -60. You want to try and come up with the ways to get -60 that would combine to give us -7. So we have -1 times 60, right? Because one's got to be -1 positive. -2 times 30. That would combine to give us 28. Nope. -3 times 20. That would give us 17. Negative 4 times 15, that's 11. We're getting closer. And by the way, if you're not sure, if you do second quit, you could do 60 divided by 4, and it will tell you that factor. 60 divided by 5, 12. All right, so negative 5 and 12. Ooh, that gives us 7. That gives us positive 7. We want a negative 7. So what if we did positive 5 and negative 12? Negative 7, there it is. All right, now that I get it, that's kind of tricky. So again, if you remember the rule with the calculator, whatever you see up here, change the sign when you put it in here. So if I see positive 6 is a 0, then x minus 6 must be one of my factors. All right. Now, what would you multiply 2x by to get negative 6? It would have to be, or what would you get if you multiplied the two of those? 2 times negative 6 would be negative 12x. And look at what just happens to be one of those factors, negative 12. Okay, what would you multiply negative 6 by to get negative 30? Positive 5. And 5 times x would give you 5x. See if that all works out. 2x squared minus 30, we already got those terms. Negative 12x and 5x gives you negative 7x. So here's one of your parentheses. Here's the other. And again, guys, I know this is tricky. It's just one method. So we add 6 to both sides. X equals 6 is one of our zeros, which we already knew by looking at the graph. This 0, however, 2x plus 5 equals 0. Subtract 5 from both sides, so 2x equals negative 5. Divide by 2 again, that looks familiar. X equals negative 2.5. Okay? And again, if you looked at the graph, that's about right. Negative 2.5. All right, couple more. I know this is tricky, just bear with me. So I'm going to bring the 3x to the other side. It's positive, so it's going to be x squared minus 3x. Now this one does have a GCF, but they both have an x. So I'm going to pull the x out. I'm left with x minus 3 equals 0. Right? X times x is x squared. X times negative 3 is negative 3x. Set each side equal to 0. So this 0 is 0. X minus 3 equals 0. So we'd have to add 3 to both sides. X equals 3. Since both of those ended up being whole numbers, you would be able to see them on the calculator. So I'd clear this out. X squared minus 3x. I should see 0 and 3. Okay? But again, if you could find those and say, okay, if 0 is a root, then x. If plus 3 is a root, then x minus 3 is one of my factors. You can use that to help you. Okay? All right, last one. And we're not going to, like I said, we're not going to spend a lot of time on factoring just because it doesn't work every time and it's confusing. All right, so here we got to subtract the 5x squared over. Since there's already an x squared, we're going to subtract it from that. So 14 minus 5x squared is 9x squared minus 6x equals 0 because you subtracted it on that side. Again, we got a GCF. 3x goes into both of those. If I pulled the 3x out, I'd be left with 3x minus 2, right? 3x times 3x is 9x squared. 3x times negative 2 is negative 6x. And then again, split it up into 2. So 3x equals 0. If I divide both sides by 3, x equals 0. 3x minus 2 equals 0, so we'll add 2 to both sides. 3x equals positive 2. If we divide by 3, x equals 2/3. All right, and that's it. If you have questions, stop by the math lab and give the practice a try. Have a good day.